this is the time. This is the time to strike because everyone needs this help. And there is nobody out there who understands plants and engineering and climate control like me.
What's up, guys? Welcome back to another episode of The Dime. I'm Bryan Fields. With me, as always, is Kellan and Finney. And this week, we got a very special guest, Nadia Sabeh, a.k.a. Dr. Greenhouse. Nadia, thanks for taking the time. How are you doing today?
Hey, Bryan. I'm doing great. Thank you so much for having me on the show. I'm stoked to be here.
Excited to have you. Kellan, how are you doing?
I'm doing well. Grateful to talk to Nadia. How are you doing, Bryan?
Yeah, I'm stoked. And we're going to get a really nerdy dive deep into some of these areas. I got a lot of questions and things that I don't really understand, but I'm looking forward to Dr. Greenhouse kind of explaining the nuances and kind of getting a simple take on some of the low-hanging fruit of things that we can improve. So before we dive in, Nadia, can you give a quick background about yourself and how you found your way to the cannabis space?
Yeah, sure. Oh my goodness. So I started Dr. Greenhouse. I'm going to start there just about 9 years ago. And so we specialize, if you guys don't know who we are, we specialize in HVAC design and climate control for indoor farms and greenhouses. So we serve all kinds of spaces as well as all kinds of crops, not just cannabis. But cannabis is just about 50% of the work that we do because there's a lot of indoor cannabis growers that need support. And so just to go back a little bit, well, maybe far back actually, but I won't go into a lot of detail. I found controlled environment agriculture working on a mushroom farm almost 30 years ago when I was an undergrad at UC Davis. And we were trying to grow shiitake and oyster mushrooms in a greenhouse, which can be done, you guys. You can grow mushrooms in a greenhouse. But we really struggled with climate control. We struggled controlling humidity inside this greenhouse, right? Because mushrooms want it to be wet, right? They want it to be cool and moist. And here we are on this greenhouse, right? That's supposed to like bring in the sun. And so I was like, oh my God, this is what I want to do. I want to help farmers control their environments to grow crops all over the world. So from that point on, I continued with my education, got my master's degree at Penn State studying air distribution and commercial mushroom farms, which I consider like the OG vertical farms. If you've ever seen a mushroom farm, they grow in like stacks. And then I did my PhD at the University of Arizona, where I studied evaporative cooling and ventilation and airflow and climate control for growing tomatoes in greenhouses. And, and while I was a grad student, right, when you are at a university, when you're in grad school, you have all these big ideas to like solve the world, right, to like solve all the problems in the world. But, it dawned on me that there was this whole other world of buildings, of architecture, of mechanical engineering where people were designing, climate control systems for people, for animals, for hospitals and laboratories and offices. And I was like, I want to go learn how to do that, how to design climate control systems for human spaces, and one day bring those ideas back to agriculture as something innovative. And so I did that for 9 years. I worked as a mechanical engineer doing that. And then cannabis went legal, right? In Colorado and Washington and state by state, right? They were all dropping and they were calling our company, the company I worked for at the time, can you help us? And it was like, hey, we happen to have a specialist in our company who can really help us design these greenhouses and indoor farms. And then at the same time, Dixon DePommier wrote his book about vertical farms. And so people, right, like it sparked the imagination of growing lettuce and growing crops indoors, right? Not just in a greenhouse, but in like a tower, like in a big, tall building. And so I was getting calls on that. And I was like, you know what? This is the time. This is the time to strike because everyone needs this help. And there is nobody out there who understands plants and engineering and climate control like me. And so I said, all right, I'm starting Dr. Greenhouse. And so, yeah, it was like 9 years ago this month, and it's August 2025, you guys, that I submitted my fictitious business name and started my sole prop. And since then, we've grown into an S Corp and I have, other engineers on the team. And it's just been a really exciting ride.
Well, first off, congratulations on the milestone. And then second,
Thanks.
what I really would love is from a cannabis perspective, I'm sure you get calls from people who they have some form of problem. And the first thing they do is say, Nadia, I have what I think is this problem. Can you help? And I'd imagine that that's not the only piece of information that you need in order to uncover where is the root cause analysis. So take us through how that approach works for figuring out like where the real root cause problem is.
Yeah, I mean, that is such a good question. When it comes to indoor plant environments, there are so many different variables that affect the environment, right? First off, the plant. What plant are you growing? Are you growing a lettuce crop or are you growing a cannabis plant? Those are two different plants, right? That need totally different lighting levels and temperature and humidity levels and irrigation rates, et cetera. And so the first thing is, right, what's your crop? And then the second thing is, what are you growing in, right? Are you growing in an indoor farm that's one level, double level, high pressure sodium, LED lights, checkerboarding, right, under canopy lighting? Or are you in a greenhouse, right, trying to capture the sun rays and the solar radiation and that full spectrum of light, right, to really express all those terpenes, right, and all that goodness in the cannabis plant. And so understanding the structure, your lighting, your crop, and your irrigation method, right? Some growers are using living soil, which has this microbial activity that also produces heat and moisture, right? Not just the lights and the sun and your plants transpiring. Other people are growing in rock wool and coco coir, which is pretty inert, right? And so you wouldn't expect all that activity to happen. And then the age of your plant, right? Like what cycle are you in? Are you in clone? Are you in veg? Are you in flower? Because one, the conditions that you're going to be trying to operate under are going to be really different. The age of the plant, how many leaves are on the plant, are we now developing flower? And so we want to stress and push the plant in a different direction. And so asking all of these questions really helps me understand, what is causing the environmental challenges that you're having. Is it a cultural practice? Is it you have bad building insulation? Is it that you're trying to use all the types of fans that are available on the market and playing with them, right? And you're just creating sort of a chaotic sort of airflow environment. And sometimes, right, I think we're going to talk about VPD a little bit, but sometimes, right, we see these temperature and humidity targets that really are not set up to allow your plant to succeed at the stage that they're growing at. And so, for a long time, when growers were growing under high pressure sodium lamps, they were targeting, 75 degrees and 50% relative humidity. And that made sense for a lot of reasons, right? One, these high pressure sodium lamps are just beating down on your plants with all this radiant energy, right? So we got to cool the plant, right? So that lower temperature was really positive. But then growers get really nervous about mold, right? Powdery mildew, botrytis. I totally get it, especially when your plant is flowering. But the problem is that low humidity actually promotes the distribution of powdery mildew spores. So those spores that powdery mildew produces actually float on dry air. So if you have a super dry environment and then you have a super windy environment, you're literally just like spreading this disease all over your farm. And so, helping growers understand that humidity is not necessarily bad. That's a lot of times one of my first goals when talking to a grower if I see that they have a really low humidity target, and helping them understand, the health of your crop, the immunity of your plant is actually benefited when there's a slightly higher humidity. The other thing, just while I'm talking about humidity for a second, is when it's really dry and your flowers are producing those trichomes, right? Like there's oil, right, on those trichomes, that really high vapor pressure deficit, that really dry air will actually cause them to vaporize, right? And I know that some of you know about Allison Justice's work at the CRC and the work that she's doing during drying with water activity. It's the same idea when the flowers are still on the plant and you're propagating the plant or you're growing the plant, is that as those trichomes are developing, still, if you have a really dry environment, right, they're not going to maintain stability. So we want to maintain that stability all the way through the crop cycle until you harvest it. And then, of course, post-harvest. So there's just so many variables when it comes to growing crops. And I think a lot of growers are learning about that interplay. You change one variable and it's ultimately going to change another variable. And so you can't just look at one thing in a silo. You really have to look holistically at the big picture.
How complicated is that when, one, you're going into these cultivation facilities and you're trying to explain all those variables that you outlined? Two, how are they tracking these elements, right? Because if they're adjusting these levers and they're not seeing the corresponding effects, or they're not recognizing like the cause and effect aspect, like they might be trying to solve a problem, which they do, but end up causing a new problem, which now they're wondering, like, did this cause, or like, how do we then get on the same page and say, okay, here are your 12 levers that you have. We need to track all these elements. And then from there, we can start recognizing the balancing act of pulling one, which causes effect of the other.
Yeah, I mean, you touch on a really important element to being, I would say, an advanced grower, is that you are collecting data and then you're reviewing that data to try to understand what the cause and effect is of a lever that you pulled or a button that you pushed, to actually pay attention and see and notice, observe really is the word, what your plant did, how it responded to that change in the environment. And so we really encourage growers to at least be monitoring the temperature in their space. And ideally, you're measuring temperature and a humidity variable. It's going to be relative humidity, but we can convert that into absolute humidity, dew point, VPD, whatever. And you want to monitor those conditions in the canopy. So one of the problems that we see when it even just comes to, are you observing the conditions in your space, is sometimes, there's a thermostat sitting on the wall and it's reading back and it's sending a signal to the HVAC unit, or maybe it's connected to your third party, right, automated control system, and it's saying the temperature is, 85 degrees and the humidity is 70% relative humidity. And so what's going to happen, right? Like the air conditioner is going to turn on and it's going to try to cool the room. But if you also had a temperature sensor sitting right above your canopy, you might actually see that the temperature is 80 degrees, not 85 degrees. Why? Because your plant, when it transpires, is evaporatively cooling itself. Right? So that process of evaporation lowers the temperature and raises the relative humidity. And so now you have this thermostat that says, cool me, cool me, cool me. But you have a thermostat above your plant that says, I feel great. What happens, right? Like now the temperature dives and your plant was perfectly healthy. And now you might actually slow down the growth. So I just wanted to mention, since you brought up, how do you monitor and pay attention to what's happening in your room, is put your sensors where your plants are, right? When you have irrigation sensors, when you have soil moisture sensors, it's in the soil of the plant you're growing, right? You don't have it like sitting in the ground in the dirt in the corner, right? Like you actually are monitoring what's happening with the plant. That's what we want to do with temperature and humidity sensors too. We want to monitor what's happening around the plant, not what's happening over in the corner on the wall over there. So back to your question of like, how do you know when you pull a lever what the response is? You got to record it. You got to write it down. You have to observe. One of the things I love about cannabis growers is that they love their plants, right? They love to talk to their plants, walk through their plants, scout for bugs and make sure that they're healthy. And so use that to your advantage, right? Take a logbook, take a pen and piece of paper and say, this corner of the room, the plants look stressed. This corner of the room, we just noticed some botrytis on some flower buds over here. And in the rest of the space, everything looks really healthy. Okay, so now that you've documented that and you have a record of that, you can continue to track that. Do those patterns continue over time? Did you just remove, the leaves that had botrytis on it and it went away? Or did you notice that it started spreading? We've seen, that in some grows, botrytis or powdery mildew will start at one end of the greenhouse and progressively move down the length of the greenhouse. But the only way we knew that is because the grower was tracking it, right? They were recording every day. They said, we found botrytis here. And then a few days later, they said, oh, crap, right? We found botrytis down here. We found it down here. Guess what? If it's in one linear pattern, it's probably an airflow issue, right? Like that's something really easy to track. So record. Observe and then record what you write down, look for patterns, look for trends. And then, one of my superpowers, I would say, is evaluating data, like looking at trend graphs. And, I can point and say, somebody opened the door right there, didn't they? And they're like, how would you know that? They're like, yeah, like the grow team just like walked into the room to do to scout the plants or whatever. And I was like, you could just tell because the temperature and humidity had a sudden change and then a sudden reversion back to what it was, right? Like there was a blip. And those blips tell you something, right? Don't just ignore them, but they also don't necessarily mean that there's something bad happening either. So it's important to pay attention to what's going on. And then, just see if that trend continues from crop to crop, from room to room, from season to season, right? Because some things are seasonal. Some things are strain dependent, right? Sometimes the shade screen over there broke down or the vent over there got blocked. And if you are paying attention to those patterns and everything has been great up until the last few days, and you notice something's wrong over there, then something's probably wrong over there, right? But the only way to know that is if you are tracking it.
So in some aspects, you're kind of like a detective who shows up and figures out, okay, where's the origination of the issue? Do we have the right tools in place? Like, do we need to move the tools in place? So the way it seems to me, it kind of feels like a little like consulting early on because you're not even sure if you can help them because if they don't have the right tools in place, they don't have the right logbook, like you could probably speculate a bunch of different concepts and ideas, but realistically, you're not really going to know until like the infrastructure is in place for you in order to go through all the data, all the steps and say, okay, here's the exact piece. Did I understand that correct?
Yeah. And, we're talking about growers who are already operating in their facility, right? We're not even talking about like new design. And you're absolutely right. So the last couple of years, I've spent a lot of time on the road visiting growers to help them troubleshoot and diagnose the challenges, the issues that they're having. There hasn't been a lot of new construction, right? Like there's not a lot of new states that are coming online. Even the states that are coming online are taking their sweet time or fighting it in the legislature or whatever. And so these existing growers, they a lot of times got HVAC equipment, I'm just going to say sucked, right? That just sucked, right? Because either they ran out of budget, the engineer or contractor that they hired had no idea, right, what a plant is. I mean, like, what is humidity? Oh, transpiration. Oh, green plants, evaporative cooling, sensible late and lows. Like, literally had no idea and still don't. It's amazing what people are still getting away with. I'll just put it that way. And so, there's a lot of compounding reasons why a grower might not have the best HVAC system. And so they're trying to figure out what can we do within the constraints that we have to improve our climate control. And, sometimes it's as easy as improving airflow. If you have a system that is not really good at dehumidification and you have higher humidity levels than even I would recommend, one of the ways to remediate that is by improving the airflow. Right. Just like for us, it's on a humid, still day, right? We feel sticky and uncomfortable and hot. And if you look at your weather app, it's like it feels hotter than it actually is, right? That's because you can't breathe, right? You can't evaporate your sweat. And it's the same idea with plants, is that if, you have this really still, humid air, they also can't sweat. They can't transpire and then evaporatively cool themselves. And so what happens, right? So now it's a humid day and the breeze kicks up and you're like, it feels good, right? Because, right, you're evaporatively cooling yourself. Same thing with plants is that if we can improve airflow, even when it's humid, we can help them breathe better and keep the transpiration pump on. But to your point, you don't really know until I walk on a site and see what equipment you have. Talk to your team to understand what they've observed, when they've observed it, where they've observed it, and, just looked around the facility. And because a lot of times growers, you guys you're so busy, right? You're doing so many things. You have so many tasks, you're dealing with upper management and the team that you're managing, right? And and like we were talking about, there's so many levers, right? There's irrigation and nutrients and lighting and HVAC and everything. And a lot of times growers become blind to the things that they walk by every single day. Not of any fault of their own. They're just, right, they got to get shit done. And so they're on a mission and they don't see the thing that's broken over here or the thing that might be causing them problems that they didn't realize that they were having. Went to visited a greenhouse in a northern climate during the winter. And I'm so glad I was there in the winter. And they kept saying that the plants grew more slowly next to the wall of the greenhouse. And so the greenhouse was insulated, right? It had glass roof and it had insulated metal panel walls. And so we're walking over there and I see there's a hole in the wall that is supposed to attach to a vent. Well, they didn't close the damper and the damper also wasn't insulated. And so literally cold, it was 15 degrees outside. Cold air is just rushing into the greenhouse. And we took pictures, right? We took temperature measurements. It was 50 degrees. It's 15 outside. It was 50 next to the wall. So the insulated panel wall was doing something. But then you measure what the plant, right, was experiencing just 2 or 3 feet off the wall. And it was it was freezing. It was 62 degrees. And I'm I think we figured it out.
Get a jacket.
So exactly to your point, there's nothing like walking the site, right? Talking to the team to really understand what's going on, right? If I just did that from my desk, I would have no idea that there was a giant gaping hole in that wall, right? Without asking you to take pictures every 5 feet of a wall so that I can maybe see that there's a hole that wasn't sealed.
How much customization by strain needs to occur for each room, right? Different strains or different sizes, right? They're going to have different evaporative cooling effects, right? Based on their bud size, their leaf size. Some are tall and skinny, right? Some are bushy. How much does that affect all of this right now?
Oh, I love this question. My dream, and I bet a lot of growers' dream out there, would be to have one strain in each room, right? That's the fantasy.
That's what all big ag says, right? If you want to commoditize it, you got to monocrop.
Right? You see those greenhouses where it's just a field of lettuce, right? Don't you wish it was just a field of butterhead lettuce, right? So easy, right? I mean, exactly. We have, so many growers are growing 4, 6, 8, 10 strains in the same room. And regardless of whether the room is 500 square feet or 10,000 square feet, trying to manage an environment for all those different phenotypes, right? Like how the plant physiologically grows is really super challenging. We have some really advanced, I'd say, growers who have learned how to steer their crops. So this goes back to that question of collecting data, observing like what happens when you make, these little changes here and there. They've learned how to steer their crops, their strains, their different strains, to make them the same height, to have the same number of branches so that they are all fairly uniform. Does that mean that they're not expressing themselves fully? You'll have to ask them. But I will say when it comes to climate management, it is really hard to create a uniform environment when you have a plant that's 6 feet tall next to a plant that's 4 feet tall, right? And it's really hard to provide the temperature and humidity that each of those strains might prefer, right? The 6-foot plant might like a warmer environment, and the 4-foot plant might like a cooler environment. Or what if we could give the shorter plant more heat so that it actually grows more, right? So its photosynthetic rate actually increased so that it grew more like the 6-foot plant. But when it comes to HVAC equipment, right, and climate control, it is really hard to isolate, right? This area is going to have this temperature and humidity. This area is going to have this temperature and humidity. This area is going to have this temperature and humidity. Because most growers, first off, have one unit per room. What is that one unit going to do, right? Like, how is it going to like put hot air over here and cooler air over here, right? Like that's imaginary. Or maybe there are multiple units, but it's really there for redundancy, right? Like a standby, like one fails. And so you have this other one that might be a smaller capacity or, just doing dehumidification to get by a power outage or something. And so it's a lot harder to control the air than it is irrigation, right? Because still, a lot of growers have 1 or 2 zones of irrigation per room, but theoretically, right? Like you could set up an irrigation system where every individual plant got something different, right? How would you do that with the air? Right? You'd have to like grow it in a bubble because even if you had like a separate air conditioner on every single plant, that air is going to mix. Right? So there's no way to really isolate every single plant or every single strain or every single area of the room from the one next to it. And so that's why I think more growers steer their plants through irrigation and nutrients. And then lighting, because lighting, you can also, there's some bleed, right? For sure. From say row to row or plant to plant, but it's more isolated than even the air is. Yeah.
Just
So
thinking.
let me add one last thing. So our recommendation is to try to grow strains that have a similar phenotypic expression. So even if you have 4 different strains, if you can grow 4 strains that want to grow at the same rate to the same height, that is really beneficial. If you can figure out, like we talked about, how to steer different strains so that one grows a little shorter and the other one grows a little taller so that they end up balancing, right, matching each other, that's really helpful. The last thing is if you can't do that, and you are going to have different heights. And I'm just picking on heights because that's the easiest one to visualize, right? Is do it with strategy. So have all the tall plants at one end of the room and all the short plants at the other end of the room. Or have all the, tall plants in the middle. Like if you're going to deliver all the air in the middle, put all the, deliver the air from, let me say that a different way. if you're going to deliver air from left to right, okay, put the short plants on the left side and the tall plants on the right side so that the air doesn't just hit a wall over these really tall plants, right? It's going to like blow over the short plants and then it's going to reach the tall plants. So there are strategies that you can work into your crop practices to facilitate better airflow and mixing and uniformity.
I could just imagine a bunch of growers just pushing all their plants to the middle and like, all right, Nadia said like this, push everyone to the side now. And then everyone like this and just pushing them all around. Well, what it seems like is that they have some predefined limitations, right? Like an HVAC system. And given those limitations, there's only a few different ways that they can kind of go right or left. And then based on those, how many strains they're doing, they've got a few other steps. And kind of working through like the if this and then statement is helpful for some, but it's really important though, it seems like to have like a defined strategy of like, what are your limitations, right? Where are your variables that you can change? And what are you tracking enough to see, you know, what are those success metrics? Because you're right, you need to be able to adjust and help the plants become happy because some ladies prefer to be with these other ladies. They need to be grouped together in the side of the room.
Yeah, absolutely. I mean, everyone has a limitation or a constraint. Sometimes there's columns in the middle of the room, right? How do you blow air around a column, right? I mean, how do you bend light? That can be a challenge. Ductwork can be a challenge, right? Just like how are you actually getting air into the room and then moving it through the room? One of the biggest challenges actually that we have faced is weird geometries. So, and by weird geometries, I mean like long and skinny rooms, like a container farm. That would be a good example, but even longer, I would say, and skinnier. And then where they're delivering the air from the HVAC unit doesn't really match how we want to then circulate the air with fans. And because if we're talking about horizontal airflow fans, which by the way is my preferred method of air circulation for anyone who wants to know, you need a certain distance to blow right in behind the fan so it can suck air, and then in front of the fan so it can blow it. But if you have these short rooms or these really long rooms, it can be really hard to pair fans up, right? One blowing in one direction, one blowing in the other. And if you have a really short room, then you can't really create good momentum with your horizontal airflow fans to get it to push from one end to the other end. And then it seems counterintuitive because you're like, well, the wall is only 15 feet away or 10 feet away. It's like, yes, but what ends up happening is that the fan, right, it blows air and it literally hits the wall. It doesn't really have any time to expand, to develop like a full flow. And so it hits a wall. And then there's a fan on the other side that's trying to suck air from that wall and push it another 15 feet away. And it basically just like the air is just sort of jamming itself. And so you never can really get a circular pattern, like a vortex kind of a pattern. So geometry is a really big deal. We've been really lucky to work with some growers early on during the building planning phase where they actually asked us specifically, what should be the shape of our room? Love that question. When we get the opportunity to tell them what the geometry of the room should be, length, width, and height, oh man, I mean, we will kill air circulation every single time. And
what's your dream? What is your dream dimension?
What is my dream? I mean, I guess
like, what's the best? Is it a circle?
Oh, well, here, it's a rectangle.
Yeah, circle seems.
Yeah, we don't want to circle.
Circle seems crazy.
I mean, there's no corners. It sounds
She's talking about like directions and walls. A circle seems very counterintuitive to that concept.
Then you can just create a world.
That's what I was thinking.
Sure,
There are corners in a circle, right? Like less friction with the corners in a rectangle or a square. Right?
That sounds fun.
Someone is very upset right now with their circle room.
Challenge accepted. Anyone who wants to take it on. Yes. So square rooms, pretty hard. I mean, the problem with square rooms is that kind of the idea of the sort of short, skinny room is that it's just a long distance to blow air, and it's really hard to get uniform conditions from corner to corner, I would say. So the rectangular room is ideal for airflow because, and when I say rectangular, I'm talking like maybe a 2-to-1 aspect ratio. So 20 feet by 40 feet or 20 feet by 50 feet type of thing. Because then we have a long enough distance that we can take advantage of that circulation pattern and really put the fans in either the wide or the short pattern. It just gives us more options. And with the HVAC system as well. So if you have a rectangular room, then you could distribute air from your HVAC unit, right, at one end of the room and pull it out at the other end of the room. And you could create like almost like a block of air going from one end to the other end. Or better yet, you could have, if you had 2 units, you could have a supply at one end and a supply at the other end, and then have the return up the middle so that then you're blowing all this conditioned air towards the middle, which, by the way, the middle is always like, right, like tends to be the more humid and least accessible area of the room. So now if you're blowing 2 air streams towards the middle, right, it's actually going to have more airflow, more air circulation, but without blowing a long distance from one end to the other end of the room. The other thing I want to mention is about the height of the room. Height helps. So, there's a reason why we see greenhouses getting taller and taller, if you're familiar with them, right? Like, there are some greenhouses, right? Some older greenhouses that were maybe 12 foot to the gutter, and then they went to 14 feet. And now we're seeing, right, like some of these Dutch Venlo greenhouses that are 20 or 24 feet to the gutter. And what that height does is that it helps to buffer heat and humidity. So, as it's hot and humid around your plant, if you have a tall room or a tall greenhouse, that heat and humidity will rise above your canopy so that it doesn't get trapped down on top of your plants. And so, if you have a short room, 10 or 12 feet tall, yes, okay, you don't need a tall room because you're not using high pressure sodium lamps and you don't need, right, 8 or 10 feet off of the plant. Now we have LEDs, they can basically touch the plant. So it seems intuitive like, oh, okay, well, we don't need all this extra infrastructure, right, above it. So let's just build a short room and put the lights as close to the plants as possible, so that we use as many photons as possible and they don't get lost off the edges type of a thing. But what ends up happening is that the heat and the humidity that gets generated at the canopy has nowhere to go, right? It just gets trapped sitting right on top of the plant. And now people are like, oh, I need better airflow. Okay, yeah, you do need better airflow, but guess what? Like your lamp is here, the top of your plant is here. How am I supposed to blow air across here? Right. And we're seeing that happen with like 2-tier, 3-tier racking systems. And there are some in-rack ventilation systems that are blowing air down, which are helping, but I wouldn't say are necessarily solving the problem either, because if you're just blowing air down, how does that air escape? That's always my question, right? How does it get out of there? Okay, that's great. We're blowing air down on it, but we're still, just churning that air inside of it. And so just give the plant some space. Just give it some space so that that heat and humidity can just escape away from it. And then you don't need as much air conditioning. You don't need as much dehumidification. If you're in a greenhouse, you can open the roof vents, which hopefully you have, to just let that heat and humidity escape to the outside, and then you didn't have to condition it at all, which is a huge money saver, right? Both in terms of equipment and energy and plant stress.
So I'm a tech nerd, right? And everything you're saying makes me think that there has to be some numbers that I'm looking for to know whether this is good or bad, right? We've talked about different spots, different locations. You're checking for airflow. So there has to be some sort of quantifiable number to know whether this is good or bad. So are there tools that you would say are absolutely must that everyone should have? And then are other tools that you say people think are nice to have, but you think are also must have?
Ooh, so I would say a must-have is, first off, just a temperature and humidity sensor in the room, not on the wall, in the room, that actually feeds back to somewhere so that you can monitor it on your phone, on your computer, and just have access to that data to make sure nothing is going wrong and that things, right, are at least going as expected, even if it's not perfect. Then I would say if you are walking through your greenhouse or your room, that you also should carry a handheld sensor with you. Handheld sensors, right, they can range from really expensive to really cheap. What I'm really looking for is relative differences, right? Hopefully the sensor that you have in the room is accurate. And so what I don't want people to get caught up in is having like a cheap sensor, hand sensor, and then putting it next to, right, their BMS, their automated control system sensor, and saying, this is like 3 degrees off, or 10% relative humidity off. Yes, it's going to be. That's okay. What I really want you to do with that is to look for those patterns, right? To be in this corner of the room, the middle of the room, that side of the room, and stand there for a few minutes, let that temperature humidity sensor stabilize, and then walk over to another part, write it down. Walk over to another part of the room, do the same thing, write it down. Walk over to another part of the room, write it down. What I'm looking for is not the absolute value, but the relative value, right? So in this corner, was it 75? In the middle, was it 80? And on the wall, was it 58? That's good enough to know that something is off, right? That something might need to be improved. Airflow or heating or air conditioning or insulation in the wall or whatever. So just looking for relative differences. Don't get caught up on, is this accurate? Just what is it from here to there? Okay, so that's one thing, is a handheld sensor. And the same handheld sensor, by the way. Don't put 3 different sensors in different places because they will all read this different thing. Okay, then I really like carrying an infrared thermometer with me. It can just be a simple point and shoot. Some people have, some fancy thermal imaging camera, right, add-ons. That's fine too. But just having a simple infrared ray gun, basically, and pointing and shooting at leaves and telling you what the temperature of the leaf is. Don't expect, again, for the leaf temperature to be the same temperature as the air, either with your handheld sensor or your fancy control sensor. What we're looking for is, I like looking at a plant from top to bottom to know, right, how is it transpiring? Because the leaf temperature is really telling you, is the plant stressed, right? Does it have heat stress, or is it actively able to evaporatively cool itself? So 2 examples. You take a temperature at the top of the plant and you take a temperature at the bottom of the plant. 2 different scenarios. You take temperature at the top and it's warmer than the temperature at the bottom. You look up and you're like, okay, it's 12 noon, it's a sunny day, and I don't have the shade screen open. Okay, that makes sense, right? There's a lot of radiant heat hitting the top of the plant, right? Like it just can't cool itself fast enough. That pattern makes sense. Okay, so then the opposite, right? You say, oh, the temperature at the top of the plant and a top leaf is actually lower than the temperature of the leaf on the bottom. Why would that happen, right? Well, it could be a couple things. One is you look up and you say, oh, it's LED lights. Well, there's no radiant heat, right? And so the plant is just transpiring on the top and it's evaporatively cooling itself. There's not a lot of heat from the light that's really affecting the temperature. Okay, so that top leaf is really happy. The bottom leaf, though, why is it hot? And then you might realize that, oh, the humidity under the plant canopy is really high. And so now the plant can't transpire. It can't evaporatively cool itself. And so it's actually warm because there's like a bubble of moisture around those bottom leaves. Or you notice, oh, my pot isn't covered, and you touch the surface of your pot, right? And you're like, oh my God, that's like so hot, right? Like, why is that hot? So it could actually be radiating heat up to a bottom leaf, which is my biggest concern. One of my concerns with under canopy lighting, if we don't have good airflow and good air conditioning under the canopy, is that we could actually be raising the bottom leaf temperature, which could be good or bad depending on, your stage of growth and what you're trying to achieve. So infrared temperature sensor can tell you about the health of your plant. It is going to be really hard to walk around pointing and shooting at 1,000 plants in your grow. So don't do that. Just pick a couple, again, spots. So I would say those are two really big ones. Now, I'm also a big airflow person, right? A lot of people come to us for advice on how to improve air circulation and air movement in their grow. And so one of the things that I carry around with me is a hot wire anemometer so that I can take air velocity measurements at multiple locations in a greenhouse or, in an indoor grow. And I take those measurements a lot of times, not always at the plant level, but where the air is being delivered into the space. A lot of growers have, these like poly tubes that are under the canopy, right? And they're blowing air 100 feet, right? A distance from one end of the greenhouse to the other. Sometimes it's 200 feet, which is way too long, you guys. And so what I'll do is I'll literally stick my hot wire probe into the duct from like beginning to middle to end. And you can see how the airflow through that tube either continues or dies. And so, growers think, oh, we're going to add these ducts or these poly tubes or fabric ducts, right? And it's going to distribute air evenly from end to end. But if you measure at one end, 5 meters per second, and you measure at the far end 0 meters per second, you might as well just have had a pad and fan cooling system, right? In fact, that might have actually been better to deliver air from one end to the other end. And I've sort of been mentioning it through this whole conversation, and I want to make sure that it's not so obvious that we miss it. But one of the tools that every grower should have is a pen and paper, right? Is a logbook, something that they're recording in every day that they can look back, right, at previous days, previous pages, to track those patterns and those trends. Don't just take a measurement and then log it in your brain. You will not remember, I promise, you will not remember it tomorrow, and you will definitely not remember it the day after tomorrow, because you just got a lot of going on, right? I mean, the age-old question, do you remember what you had for breakfast yesterday, right? So keep track, right? Write it down. I've seen some growers, that have big teams. They actually have like a log. They have like a clipboard and like a log, a piece of paper where anyone who goes in to scout, because it might not be the same person, or it could be the same person, they write down what the temperature and humidity and air velocity was at prescribed locations. And then every day, or maybe a couple times a day, there's someone going in there and recording that. And so even if you don't have a fancy control system or monitoring system that's automated and collecting that data and tracking it for you, you can do it yourself, right? Like you can write it down and see if you got the same conditions today as yesterday, as the week before, as the month before. So I would really recommend doing that on a crop by crop basis, right? So every 9 weeks, I don't think you need to, after you harvest your crop, continue on the same track, but keep that piece of paper, put it in a binder, because you will be interested to know as you moved from summer to winter if you saw those same trends or if they changed. So
what about a tool or technology that doesn't currently exist that you would dream for if it did exist?
Oh, I don't know if I have one of those. I have to think about that. Less expensive sensors.
Yeah, sure. No, we all want that. World peace
Dare to
too.
dream, right?
While we're at it, world peace seems great also. Like cheaper groceries.
Sensors are expensive. They were expensive before inflation, especially if you want something that is accurate. Yeah, I don't know. Thank you for making me think about that.
They're valuable, right? I think that's the aspect that's so interesting, is that sensors aren't new for their value they provide. They're commonly used in all the other industries, and cannabis has been a little late adopting some aspects of the sensors, very artisanal, and I understand the importance of that, but the sensors there provide stability and metrics that are just unable to be achieved through just a normal eye, right? You're quantifying things that are really difficult, so that when you do field questions from the grower, you can ask them, what was the humidity at this time? What was this temperature at this time? And without those numbers, you could say it's a little hot, a little cold. That's not really so helpful for you.
Right. And it's relative a lot of times subjectively to you, right? That's one of the big challenges with climate control or with just monitoring your temperature and humidity, is that what you think is hot or humid might not be to your plant. Right. And so, and vice versa. So, putting our sensibilities and our experiences and to sort of personify the plant, that's what the plant would like too, is what I think is most comfortable, is not always true. And, for growers who are familiar with plant empowerment strategies, one of the strategies is that as the humidity increases, you raise the temperature, because as you raise the temperature, it maintains the target vapor pressure deficit, because the absolute humidity won't change. The amount of moisture won't change. So you raise the temperature, which drops the relative humidity and maintains the VPD you want. But the problem with that is it's developed for tomatoes. That's one problem. The second problem is that it is really uncomfortable to be in that space, right? If you just keep raising the temperature from 80 to 85 to 90 to 95, okay, so your plant is comfortable, but who is going to work in that space, right? Like, nobody wants to work in that space. And so that's kind of one of those practices that in theory works to a point, until all of a sudden nobody is going to walk into that space because it's so uncomfortable. And you start risking other things at a high temperature as well. So, there are constraints, there are limits, but don't necessarily think that your plant wants the same conditions that make you feel comfortable. But they're also not that far off either. So if it does feel chilly to you, it's probably cool to them. If it feels really hot to you, it probably is hot to them. And that doesn't mean that they're not going to survive through that, right? I mean, plants live outside. I mean, they survive under all kinds of conditions. The goal is to make them thrive, for one. But plants are also kind of like kids. They're resilient. And there are things that you can do if it's really hot during the day. If you have a way to cool them down to a lower temperature at night, then it's actually the average daytime temperature that they respond to more in terms of yield and productivity than the extreme high or the extreme low. Yeah, yes, again, there are limits, but there are ways to get through it. And the other thing is, we haven't really talked about the connection with the root zone, right? And so if one of the tricks is, if you're growing hydroponically, if you're drip irrigating, you are delivering water from an irrigation system, from a fertigation system, not really for soil, but it works pretty well for cocoa and rockwool, is that if you can lower the water temperature, or at least prevent the water temperature from going above, say, 70 degrees, and it's 85 or 90 degrees in your greenhouse or in your farm, you can basically cool your plants' feet and reduce their heat stress. I always think about that for myself, talking about personifying a plant. But sometimes when I'm in the car, right, like I will actually turn my air conditioner onto my feet because it cools me down more quickly than if I blow it, in the full compartment. Kind of like if your feet are cold, right? You can stick your feet in a hot bath type of thing and it warms your whole body up. So it's the same thing with the plant, is that if you can cool the water down, if you can cool the media down, then that can actually reduce the heat stress that it's experiencing above the root zone in the air. So that's a trick for all of you. If you have a way, black pots absorb heat, so try to avoid those if you can. Of course, white pots, and get algae type of thing. There's trade-offs to everything.
So last question, what would be one takeaway for those listeners to improve or to benefit, or things to look out for if they had an opportunity to ask you any question?
God, there are so many things. So one, we talked a lot about all the different interactions between the variables in your farm, right? In your grow, right? From the irrigation and nutrients to the environment. If you have a really dry environment, right? We talked about that could help spread powdery mildew. But also, and it could vaporize some of those trichomes, right? And terpenes when you want to keep them on the flower. Another thing is that if they are transpiring really hard and evaporating a lot of water, that also means that they need a lot of water, right? Which means that you have to irrigate them more and use more fertilizers, right? To give them the nutrients that they need. That, again, having a really dry environment might seem like a good idea, but actually could cost you a lot in the end. So a lot of connections between the various variables. A lot of people are really interested in under canopy lighting to boost yields, to boost photosynthesis, right? Get light in those under canopy leaves. There is, some data that shows that it does increase productivity, but we're also seeing higher rates of botrytis and mold growth on those under canopy leaves because there's not good airflow underneath. If you think airflow above the canopy is challenging, now try to get airflow under the canopy as well. That's really challenging. The other thing I just want to mention is about the HVAC equipment that you have and the importance of servicing and maintaining that equipment. It's just like your car engine, right? Like you want to change your oil every few months, every few thousand miles, assuming you drive a combustion engine car these days. And even if you didn't and you have an electric car, you want to replace the air filter, right? The cabin filter, because air comes in from the outside and into, where you're driving. And so you want to replace that filter. So there's still maintenance to be done no matter what type of equipment you have. And so the same thing is true with your HVAC system. Change those filters, the air filters, every crop cycle at least. Wash down the coils if you can, even just water. Just rinse them off because they're going to have a lot of dust and debris from, all the pruning activities that you had and, the oil that's in the air. If you just use water, that can sometimes be better than using a coil cleaner because that can actually be abrasive and corrosive. So be careful of those. And, hire, if you can, a qualified service technician. They are hard to come by. I will tell you, I know that that's an issue. But do try to find someone to support you to at least do some annual maintenance or seasonal maintenance for you guys. So yeah, those are just a few final takeaways. there's so many topics we can talk about, coming up. Thank you, Bryan, for asking about tools, because we are actually putting together a toolkit package of exactly the things that I just mentioned, because I want growers to be armed with the tools that are going to help them every single day in their grow, whether I show up on site or not. Because honestly, I can, if you are taking measurements, then I don't necessarily have to go on site, though I love to go on site and talk to all you guys and learn about what you're doing. But if you've collected some preliminary data with the tools that we give you, then you can share that with us and we have a starting point for our conversation. I'm going to be speaking at a couple conferences coming up. Those of you might know Tad Hussey at Kiss Organics. He's putting on a cannabis science conference in Montana at the beginning of September. I think this podcast is going to drop a week before that, so you'll still have a chance to register and come join us. I'm going to do an airflow workshop, actually, and Suzanne Wainwright will be doing a bug workshop. So that'll be fun to do out there. And we're putting together what I hope are some easy button options for you guys on our website. We realize that finding qualified engineers and contractors to size your equipment, to help you operate your equipment, isn't really easy to come by. And so we want to make it easier for you to contact us and for us to help you with some of the basics to make sure that whoever you're working with, that they're giving you the right numbers and the right advice, and we can just provide you with some foundational knowledge to make sure that they're telling you the right thing. So, yeah.
Love it. So, Nadia, if our listeners, they want to get in touch, they want to learn more, where can they find you?
Awesome. So you can contact me at my email. It's nadia@drgreenhouse.com. Dr. Greenhouse is all spelled out. And then you can find me on LinkedIn, on Instagram. Some of you might listen to my podcast. The Doctor is in. We just wrapped up an energy series all about energy and CEA. If you have any topics that you want us to cover and take a super deep dive into, we are all ears. And you'll probably find me at a conference. I'm at a lot of events. So track me down. I'd love to talk to you.
Thanks for taking the time. This was a lot of fun.
Thanks, Bryan. Thanks, Kellan.